13.9, Part 2. In Part 1, we learned that if f has an extreme value at the point AB on the constraint curve g equals 0, then the gradient of f is equal to lambda times the gradient of g. When we move into functions of three independent variables, the constraint becomes a surface. The objective function lies in four-dimensional space, but we can still view its level surfaces. And comparing gradients, if f has an extreme value at the point ABC on the constraint surface, then the gradient of f equals lambda times the gradient of g at that point. Let's do an example. Find the least distance between the point 3, 4, 0 and the surface of the cone. Choose the objective function to be the square of the distance between x, y, z and 3, 4, 0. We're choosing the objective function to be the square of the distance in order to make our work easier. The constraint on x, y, z is that it must lie on the surface of the cone. So we choose g in this manner. Then a point xyz lies on the surface of the cone if and only if g equals 0. We are now going to find values x, y, z such that the gradient of f equals lambda gradient of g and g equals 0. Rewriting the gradient equation, we see that we need to solve these four equations simultaneously. Set up the equations. The simplest equation to start with is the third. For that equation to be true, either z has to be 0 or lambda has to be -1. Case 1, z equals 0. If z equals 0, then the fourth equation becomes x squared plus y squared equals 0. That will only happen if both x and y are 0. But this causes a contradiction of -6 equals 0 in the first equation and -8 equals 0 in the second equation. So there is no solution for case 1. We now move to case 2. If lambda equals -1, then we rewrite the first and second equations. Solving for x and y, we get x equals 3/2 and y equals 2. Put those values into the fourth equation. Solving for z, we get 5/2 or -5/2. So case 2 gave us 2 points and case 1 gave us no points. And there are 2 points to consider. What are these 2 points? Well, the value of the objective function at those 2 points The value is 25 over 2. Is that a max or a min? If you look at the geometry of it, then you can see that these 2 points correspond to the minimum distance. If we move away from either one of these points, if we move to another point on the cone, the value of f will increase. Therefore, these 2 points correspond to absolute minimum values and are the points on the cone nearest to 3, 4, 0. Since f equals 25 over 2 is the square of the distance, we need to find the square root now. And both of these points are a distance of 5 over radical 2 from the given point.